2023. Will you please join me for a minute of silence? Thank you very much. Will you please stand as you're able for the pledge? I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you very much. Have a great day.
Okay, we got two things. We need to check off our list today and set us up for our law of sines, law of cosines quiz next class. So the handout you guys picked up this morning is number 60. So that should be treated as a practice quiz to give you an idea what type of questions you need to ask, and if you need to do any studying, what type of questions to look at, and approximately how much time you need to put into that. So before I take your book questions from number 59, as I promised I would, since you didn't have time to finish that in class last time, you may have had some questions outside of class. I just want to speak on this practice quiz real quick because I know some of you won't have any questions, and I just want to make sure you're approaching it correctly. To do this practice quiz, I would have your notes out, but question 1 and 2, when to use the law of sines, when to use the law of cosines, you should not be using your notes on those. We will ask you that on the quiz and expect you to know that. But the formulas that you need for question 3, 4, 5, 6, 7, 8, 9, and 10 will all be provided for you. We don't expect you to memorize the law of sines, the law of cosines, or either of the two new area formulas. Of course, you know, it may help you in the future someday, but for how much time we spend on this unit and just trying to get you familiar with it for the ACT, that's kind of the trade-off. Try to make it easy for you, but we also don't give you a ton of time. So, just to be clear, questions 1 and 2, don't just look at your notes, see what your notes say, and think that you know that. You need to make sure that you can do those two without your notes. Okay, so this should make for a fairly easy class period, but if you do have any book questions, please go ahead and get those out and let me know what they are. And if you do not, you can tune us out and move on to the practice quiz. The website, of course, has the solutions for you to check your work and to make sure that you don't need to ask anything. And the website also has an extra practice worksheet that we used to require students to do that has a lot of good extra practice if you feel like you need it, but that's completely optional. But of course, that extra practice has solutions and quite a few solution videos. So just want to make sure that you're aware of that. And then I guess finally, while everyone else is still getting out their book work, for those of you that had some questions left over, I did open up these two assignments into Google Classroom. So just like last semester, if you prefer to turn it in early, you're welcome to do that. Otherwise, make sure that you have it completed with your name on it and ready to turn in before we start the quiz on Monday. Okay, so for those of you that had some more book questions, what questions did you have and what page were they on? I just need to know if it's from 6.1 or 6.2. Number 9 on what? 415? Sure. Okay, so this is from the second part of the assignment in 6.2. So that gives me a hint on which formula I should be using. But just like your practice quiz that you guys picked up this morning, the quiz isn't going to say, hey, you need to use law of sines on this one, or hey, you need to use law of cosines on this one. Part of that is seeing that you know two sides and their included angle, the angle in between those. And when you have that, that is law of cosines. Now, that's not to say that you couldn't also use law of sines sometimes, but this is what they're intending you to start off with. In fact, you could not start this question with law of sines. You need law of cosines. So, law of cosines can find you an angle if you know all three sides. I don't know that yet. Or it can find you a side if you have side angle side. So if you're trying to find a, you would need to look at your formulas, and there's a formula that will say a squared is equal to b squared plus c squared minus 2bc cosine of angle A. So one thing that I do, this doesn't happen to students too often, but it is kind of unfortunate when you forget to do this, but at the end you should take the square root. So I just go ahead and do it all in one step. Plug in 15 for B, 30 for C, 15 for B again, 30 for C again, and 30 degrees for cosine of A. So assuming your calculator's in degree mode and you type it in just like that, there shouldn't really be any issues finding side A. Again, I know you're sick of me saying this, but we will provide the formulas for you, but just don't eyeball them so quick that you accidentally put a sine here instead of a cosine. Law of cosines has cosines in the formulas. Law of sines have sines in the formula. Okay, so that's what my calculator gave me for side A. You alright with that? Okay. And then it said solve, so we also need angles B and C. So I guess in theory, as long as you keep up with all of the decimals for side A, or you store this in for side A, you could technically use law of sines now if you want to for angle B or angle C. If you really, really prefer that and you think that's the easiest path, then by all means, that's what you should do. I'm going to go ahead and use law of cosines again. I think it's all about the same anyway. So if you go to your law of cosines formula, one of them will say cosine of B is equal to a squared plus c squared minus b squared over 2ac. And just like I go ahead and take the square root of this at the beginning, honestly, what I do, just so I don't forget, is I do inverse cosine, and then I'm going to throw those numbers in. So I've got to use this number for A, but I am going to store that as A in my calculator so that it's not rounded, plus c squared minus b squared over 2 times A again times C. Now, this was one of the few big questions that last period had about they were typing this in and they were getting a different answer. And the reason why is if you guys are typing this in the calculator, inverse cosine of this squared plus this squared minus this squared divided by 2 times this number times 30, your calculator is doing the order of operations exactly as you ask it to. So it's doing this division and then coming back and doing adding and subtracting later, because division becomes before adding and subtracting. So either A, you need to put this big fraction in your calculator by doing alpha y equals number 1, or just put parentheses around your numerator and parentheses around your denominator. It never hurts you. Like 2 over 4, you don't need parentheses around the numerator and denominator, but it doesn't hurt you to put them there. But in this case, If I don't do that, if I don't put these red parentheses, then it is going to either give me an error message or it's going to give me a number that's not actually true. So in mathematics, anytime we write a great big fraction like this, it's implied that you do all the numerator stuff and then all the denominator arithmetic and then divide. So there's implied parentheses that we just don't write. But putting that in, my calculator is giving me about 23.794. And I don't know if I'm going to need that for the last part, but I'm going to go ahead and store that as B just in case I need that. So that way it's not rounded. It's fine to round your final answers, but don't round in the middle of the question. Okay, and then angle C. Now you've got tons of options. Law of sines will be fine. You could do law of cosines another time, but probably the quickest way is, you know, 2 of 3 angles. So if you just subtract the 30 degrees that was given to you minus the one that we just found, that means that the last angle should be that. Again, our quiz is only like 30 points, I think, but you know, if you have some extra time, sometimes a good idea is to find that last angle using law of cosines and then also find it by subtracting the other two from 180 and make sure you're getting the same number. Because if you're not getting the same number, you might not be doing something correctly, and it at least gives you the chance to fix it before you turn your test in. So this one we had to start off with law of cosines, and then we had a lot of options, but I used law of cosines for the second angle and then subtracted 2 angles from 180 to find the third angle. Anybody that had this question also have anything more specific about it? Okay, what else you got? Sorry, what was that?
Can you do 415, number 47?
Number 47. You said 413? Okay. So it looks like it gives us 1, 2, 3 sides, and this one's saying use Heron's Aaron formula to find the area of the triangle. So you don't have to really know that this is called Heron's formula, but it is a very, very famous formula, so you'll probably hear that at some point in the future. But Heron's formula is one that it can find you an area of a triangle. So as long as you know when to use it, we will have this for you on the formula sheet. And we will even tell you how to find S. Be careful, this is not divided by 3, it's divided by 2. It's not an average. And so in your calculator, you're going to need to ask it what is 6 plus 12 plus 17, and then divide all that by 2. So 29, 35 over 2. And then that's going to get plugged in 4 different places. And instead of putting A, I'm going to put 6. Instead of putting B, I'm going to put 12. And instead of putting C, I'm going to put 17. But throwing that in the calculator should give us our answer. Now, I feel like I've been preaching about this store button. I know this is only the second day you guys have been back, but the store button is going to be nice for this S value as well. So 6 plus 12 plus 17 over 2. Since this is a fraction or a decimal, like, I guess it's not that hard to do 17 halves, but the way I had it written, 35 halves, 35 halves, 35 halves, 35 halves, 35 halves, it gets to be where you might make hit a wrong button or something in your calculator. So just another case, just to play it safe, I like to store that as S, and then I can go in and plug in the rest of the formula. And just notice that instead of doing 4 different fractions there, it's a lot easier to store as S and let it deal with that. And so then that should be your answer on 37.
Did you also do 47?
What did you say, 47? There's actually, I tried to limit it a little bit because if you kind of look at some of these questions, there's some really interesting and quick applications that you can do. So I try not to do a million of them for you to see if you can do law of sines or law of cosines. But this one is the one that we had picked out that we thought was a little bit more interesting. We've got a baseball player in center field, and he's 330 feet from a television camera. That's behind home plate. Batter hits a fly ball that goes to the wall 420 feet from the camera. And the camera turns 8 degrees to follow the play. And with that, we can figure out how far this player in center field has to run to go and catch that ball. So now that it's just a generic triangle, I can quickly see I have 2 side lengths and the angle in between them. Side angle side is the one that works out great with law of cosines. So if I call this angle A, then I guess this would be side A. And so one of your formulas looks like this. And I would go ahead and do square root right away just so I don't forget it. But otherwise, call one of these sides B, plug it in for B, call a different side C, plug it in for C. You have to plug in B again, you have to plug in C again, and then you have to plug in angle A there. But assuming that we don't hit a wrong button, then that should be it. Should work out fine. I'm getting about 104 feet. So I guess I don't know why you would necessarily care how far someone would have to run, but I guess if you knew how quick they were at running, you would have a good idea if they could actually get to it or not before it hit the ground. Something like that. Okay, is that enough for 47? Okay. All right, somebody who's not asked a question, let me give you a chance to ask one before I give others more chances. Yep. Number what?
45.
45. And the second part?
Yes.
Okay. All right, 45 from page 414. Okay, so this one we've got we're trying to figure out the distance across a swamp or a marsh. So somebody walks this way and measures that it's 220 meters. And then they turn, making a 75-degree angle here, and then they remeasure so they're 250 meters, and then that's supposed to represent the distance across that swamp, and then that's what we would like to know the distance on. So first thing I notice is I've got two side lengths, and I almost have the included angle, so that's almost law of cosines, but I don't quite have it yet because I would need to know this. But it looks like these two make a straight angle. They make up half of a circle, so together if they add up to 180, that means this one would need to be 105. And then, I don't know, you can label these sides and angles anything you want to. I would probably stick with A, B, and C, just so it looks like the formula a little bit better. But call one side A, one side B, one side C. Pick the formula that goes along with that. So based on how I numbered them, I would pick out this one because I know length B, length C, and the angle A. My suggestion would be to put the square root in there right away so you don't forget about it. But plug in 220 for B, 250 for C, 220 again, 250 again, and the angle opposite the side you're trying to find goes in for A. And this is one's a little bit easier to put in because there's no fractions, so we don't have to worry about any parentheses or anything like that. I will say that, you know, this is a unit that's usually very good for students, but if someone was to miss a bunch of these questions, it's usually something like this. They don't include this too. And again, we provide the formulas for you, so you should be double checking that, but it is very unfortunate when people miss a handful of points for something like that. Of course, I still try to give partial credit, but and then that's what my calculator says, about 337 meters. And since that has to be the biggest angle opposite that, it makes sense that it was the biggest side. Probably correct. So side angle side, but we did have to do just a touch of work to figure out what the angle was. Okay, one more chance for somebody who's not gotten to ask a question yet today. Okay, somebody who has asked one, have some more. Alright, so let me, I know some of you have been working on the worksheet, some of you haven't, but let me set 10-15 minute timer up here, so then I'll come back and ask you for some questions. Again, the solutions are online for that, but I did have to make them up this morning, so there's not any work shown with them. So if you don't have that answer, you will need to make sure that you ask about it. And again, just for clarity here, you do not have to memorize the formulas. Use your notes to see the formulas that you need. Just make sure you're not using your notes to answer question 1 or 2.
Avenue seats.
Yeah, I'm sorry, I have to look it up. I don't have it memorized.
Yeah.
You were number
Don't worry.
5, so it'll be right back there.
Thank you.
Yep. It's been close to 15, so I don't suspect you're finished with the practice worksheet, but is there some questions you're finding that I could help with?
Number 4.
Number 4? Okay. That's the one that my last class asked about as well. Alright, so number 4 gives 3 side lengths, side, side, side. Now, of course, you're welcome to sketch a triangle, and you could try to make it to scale if a visual helps you a little bit. But really, as soon as you see side, 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 you should know that that is law of cosines. So you go to your formula sheet, and 3 of them are for cosine of A equals, cosine of B equals, and cosine of C equals. So I have it written out here. I didn't type it in my calculator yet, but if you're trying to find angle A, use cosine of A equals, and just like the square root thing, you can square root at the end, and like these, you can do inverse cosine at the end, but I think it just makes sense to go ahead and do it at the beginning and plug those numbers in. So my concern is, well, 1, you need to be in degree mode. But then 2, if you're trying to find angle A and the formula says do B squared plus C squared minus A squared over 2 times B times C. First off, it may give me an answer here, or it's going to fuss and give me an error message. I think this one gives an error message. And the problem is, like this, it may be how we wrote it down on our paper, but again, your calculator does order of operations very strictly. So it's going to do this division, well, it's going to do the exponents first, PEMDAS, but then it's going to do this division, and then this multiplication, and then this multiplication, and then it's going to come back and add, and then it's going to come back and subtract, which is totally out of order for what you intend for it to. So this is one of the cases where you need parentheses around your numerator so that it does all that stuff first. And parentheses around your denominator so it does all that arithmetic before it does the division, because that's what we intend for it to do. And then that's what you should get for angle A. And then angle B is almost the same formula, but the stuff's in a slightly different order. So for B, it would be A squared plus C squared minus B squared all over 2 AC. So again, the numbers are in slightly different places, but still using the same lengths. And then there would be angle B. But you have to do one of 2 things. Either put parentheses around your numerator and around your denominator, and if you don't know when it's necessary, then just do it every time. Or you can do this alpha y equals option number 1, and you can do fractions that way as well. So I'll type in the same thing and show you what that looks like in case you want to use that. Alpha y equals 1, and then you don't have to put in the parentheses because it makes it one big fraction like the formula looks like. It puts in the implied. Oops, I don't even need that parentheses, but I do need parentheses there. Same thing. Okay, is that enough on that?
Yeah.
Okay. Okay, somebody have maybe one more from the practice quiz that's ready to go? Jada?
Number 7.
Number 7. All right, same thing, there's no picture here. So if you wanted to sketch a generic ABC triangle, and even better if you tried to make it look kind of to scale, side B needs to be a little bit longer than side A, then you can. But it's completely unnecessary because this is one of the area questions and we are providing you with 2 new area formulas. So one of them is Heron's formula, which you need in question 8. And the other one is when you have side, angle, side. And again, we will provide these area formulas for you. But one of them says 1/2 AB sine of C. And that's the information that you have. You have side A, you have side B, and you have the angle, included angle, the angle in between those. So we only briefly talked about this in your notes just because I don't want to bore you to death about where they come from, but I showed you one. This is still really 1/2 base times height. It's just that they're not coming out and saying the height is this. The height is coming from a SOHCAHTOA equation, but the SOHCAHTOA equation has been done for you. And put that in your calculator and it should come out to that. I will warn you, we're providing the formula and almost everybody will get that question type right, but if you miss it, there's about a 99% chance it's that you forgot the times 1/2. Just like area is 1/2 base times height, if you don't do the times 1/2, then it's going to be twice the size of what it's supposed to be. So again, it wouldn't be more than a point or two, but I'd hate for you to miss points on something as silly as that. Okay, let me give you a little bit more time here, and then I will bug you for some more questions. So go ahead and keep on going. As you guys finish, please consider go ahead and put them in Google Classroom just in case you forget them on Monday. If you've not put an alarm or an alert of some sort about the quiz on Monday, then that would probably be a good idea. It's been like a month, I think, since we've had a quiz, and you guys are not in full swing of school again. So over the weekend, I would, pre-cal quiz is not going to be the top thing on your list, so please write that down somewhere so that you don't feel like you're caught off guard. This is meant to be an easy unit, but we're going to just have this one quiz, and then we will move on to limits and stay in that for a few weeks. Just a little over 20 minutes, but I think most of you are getting close to being finished with the practice quiz. Anything else that you have found yet that I could help with? Yeah. Number 10. Okay, question 10 says we've got 2 ships leave port at 6 a.m. One travels with a bearing of north 52 degrees east, so that would be this guy, and he is going 12 miles per hour. The other one travels south 22 degrees east, that would be this way, at 8 miles per hour. Find out how far apart the ships are at noon that day. So if this one is here and this one is here, then this is what we're trying to find. But one thing that you need to be careful about is that we want this to be how far apart they are. So this should be a certain number of miles. And so for this side of the triangle to be miles, you need these sides to be miles. So you don't want these to be a speed and this to be a length. That doesn't match up. So that's why they're giving you this. If you start off at 6, how far apart are they at noon? So they've been traveling 6 hours. So 12 miles per hour for 6 hours would be 72 miles. Now it's a distance. 8 miles per hour for 6 hours would be 48 miles. And now that they're all in miles, it's going to be a little bit easier. But I do also notice that I can almost use if I call this A, this would be side A. I can almost use law of cosines and use this formula. But the thing that's missing, if you go ahead and just start plugging stuff in, that I don't quite have, is this angle A. To use law of cosines, you've got to know the angle opposite the side that you're trying to find. But the fact that they gave me that this is 52 and this is 22 and all 3 of these make up half of a circle means that they should total up to 180. So subtract away this 52 and this 22. So it would be 74. So that would be leave behind 106. Half of a circle is always 180 degrees. And then you throw in 106. And then I'm going to put all this in my calculator, but it should come out to be about 97 miles. Yes, and it does. Okay, is that enough for that? Anybody else that was going to ask about number 10? Any of that you need me to speak on again? Okay, any others from your practice quiz that are ready to go?
Number 6.
Number 6. Okay, so question 6 gives two sides and an angle. It wants us to find side D and angle E to the nearest thousandths of a degree. So, I don't know, I've recommended this on a couple of previous questions, but I hadn't actually done it myself. But again, it's not a terrible idea to just sketch a triangle DEF so that you can maybe label some of this stuff. That visual seems to make it a little bit easier. Certainly makes it easier for me to realize I have side, angle, side, which would be a law of cosines strategy. Now, one thing about this is you go to your formulas and they may look like, oops, a squared is b squared plus c squared minus 2bc cosine of angle A. And that, I don't know, this is talking about A, B's, and C's, and this is talking about D's, E's, and F's. So you just need to switch this. If you're going to switch A to be D, then angle A needs to be angle D. And if instead of calling this B, we're going to call it E, then it needs to be E here as well. And instead of calling this C, we call it F. Make sure that you're consistent and change this C to F as well. And now it's the same thing. So in my calculator, to find side D over here, I should be able to do E squared plus F squared minus 2EF cosine of 100 degrees. And I will plug that in to make sure that does give me that last side. And 15.799, so that worked out just fine for that one. And then you still need angle E, and you honestly have some choices here. Notice this question doesn't say anything. You have to use law of sines, you have to use law of cosines. Sometimes you have to start off the problem a certain way, like this one has to start with law of cosines. As much as you may like law of sines, you just don't have the right information to find it. You'd need two angles to find a side in law of sines. So, but at this point you've got some options here, but I will say no matter what option you pick, I think you're going to need to use this side D. So in my calculator, I am storing that in for D because I don't want to keep up with all 8, 9 decimals. But most important, this rounded answer is fine to write as your final answer for part D or side D, but don't use that rounded answer to help you find a different answer. So finally for part E, if I want to know E, well, let's say I look at the formula and it looks something like this. And again, I don't have A, B's, and C's. I have D's, E's, and F's. So if I just try to be consistent here, I changed A to be D earlier. I called B, E, and C, F. And just make those switches. And so it looks like to find the measure of angle D, we should do inverse cosine of E squared plus F squared minus D squared. So I'm using what I have stored in my calculator so that it's not rounded, all over 2E f. And since this is one big fraction, I'm going to double check my answer here. But when I type this in my calculator over here to the side, remember you do need parentheses around the numerator and parentheses around the denominator, or it will not do the arithmetic in the order you're expecting it to. And oh, what am I doing? First off, I shouldn't be trying to find angle D. Angle D was given to us. I was supposed to be trying to find, what's it, angle E. Oops. Okay, so if I'm trying to find angle E, I need to adjust this a little bit. This would be D squared plus F squared minus E squared, and this would be over 2DF. So switch those two and make that be D. And then that does give me the 54.129. I'll add here at the end, if the D, E, and F is the part that's giving you issues over it being A, B, or C, what you can do just over to the side is give yourself a little key. Like instead of saying E, I'm going to refer to that as A. F can be like my B, and D can be like my C. And then you can still use the formulas, but when you get an angle A side A, angle B side B, angle C side C, you can go over here and use your little key to see that you actually have E, F, or D accordingly, and then you don't have to worry about mixing them up. But of course, the mistake I made was make sure you're paying attention to what you're trying to find. I already knew angle D, and I wasted a couple minutes trying to find angle D. I didn't change it here. I was supposed to be finding angle E. So. Alright, we are down to about 10 minutes. I know we've looked at several of these, but anybody else have any others you want to ask while you got a chance? Uh-huh. Just the angle part? Okay, so if this is 130 and this is 100, you're okay with this being 30. Over here, you only have this 30-degree angle, and you really need this 130. Notice I use it right here. So the way I found this 130 is I took 180 minus this angle that I had right away, minus this angle that I found, which is where the 130 came from. So then it comes down to, how did I know that this was 20? Well, the reason I knew this was 20 is because these three make up half of a circle. So I knew 180 minus this 30 minus this 130 is where I got that the last piece has to be 20. But ultimately, the order that I really did it in is I found this 130 down here. And the way I knew this was 130, I had no other angle tricks to help me move forward, but I had parallel lines. I looked at this line as a transversal. This angle up here, that's 130, is in the top left of the transversal, so he alternates with the bottom right of the transversal, and that's how I knew it was 130. So I did that first, because that was, again, I don't go to that right away. It's just that when I don't have any other angle tricks, and especially if I have parallel lines, then that's usually a convenient way to do it. This is 130, so this is 130. These have to add up to 180. So if this is 130 and this is 30, this had to be 20. And then finally the last three had to add up to 180 because they were angles of a triangle. So 180 minus 30 minus 20 gave me 130. And then I needed that to use law of signs. And that came up a couple times in the bookwork, so I would expect it to maybe show up once on the quiz. So that's the type of thing that you might want to highlight in your notes. That's, even if you know how to do that, it's good to review it so that it's just mentally near the top of your brain when you come in for the quiz. Okay, we got about 8 more minutes till we're dismissed, but let me go ahead and give you some of the directions one more time, just to be clear. I will take up 59 and 60. Feel free to turn those in early in the Google Classroom. Obviously, your grade gets reset for our semester, so right now you have no grade, but those will both be 2 10-point assignments. Just like last semester, if you do them completely and on time, then those will be 100. That's how I do almost all of that. So, you know, if you're looking to improve something from last semester and you were not getting hundreds on all the homework, then that's an easy way to help bump up your grade. But make sure you have those 2 done. Turn them into Google Classroom if you want to turn them in early. Otherwise, make sure you have them ready to turn in before we start the quiz. Make yourself a reminder so you don't forget about the quiz over the weekend. And I think that's it. But if y'all think of something else, y'all can ask before you go.